Hi. Last time we finished discussing ISLM model in a linear version. But look, just like we had at the beginning with national income model that we first did for closed economy, ISLM can be extended to the open economy version. And this open economy version is called ISLM Bp model. And this is the model that we are going to discuss today. And look, just as before, we're going to use as a starting point what we already learned about ISLM, and we're going to extend it by introducing the elements of open economy. Okay, so here we've got our standard set of equations for IS curve. As we remember, IS curve represents all the combinations of interest rate and income for which there is an equilibrium in a market for goods and services. So this is 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 basically associated with production, with what we produce, the goods that are being produced in the economy. However, as you already know, when we want to open the economy, we need to introduce the prospect of either us being able to sell goods that we produced outside, or outside countries, foreign countries, selling the goods to us. And we did it by introducing net exports. Today, we're going to do just the same thing, but we're going to do it in a slightly different way. What I'm going to add over here is going to be expression CA. CA stands for current account. Current account is a slightly more general term than trade balance or net exports that we've been using, because it also registers, for example, transfers of income. Because trade balance is generally dominating the current account, we're going to assume that our current account is actually just a trade balance, which will not make a lot of issues for us. So, what is this current account? Well, current account is simply the difference between exports and imports. So it's still a trade balance. However, there's going to be something new. Look, before, we just had autonomous exports, and we're still keeping them. We are not going to analyze impact of foreign income on our exports for now. And so this stays. We are assuming that the outside countries' GDP is exogenous to us. We do not have any means to influence it. Then the second thing that we already used is expression negative m times y. Again, I remind everyone that m is marginal propensity to import. It is somewhere between 0 and 1, but we are assuming conventionally that it is far lower than B, marginal propensity to consume. And it simply tells us how much out of one additional dollar domestic residents are going to spend on foreign goods. Okay, so those are the two components we already had, right? Now, let's introduce one important thing that we did not have previously. And the expression we're going to add here is lowercase v times e. What is e? E is nominal exchange rate. And as you can probably guess, exchange rate has it plays fundamental role in determining net exports, because it's actually showing us what is the cost of purchasing foreign goods or selling domestic goods in foreign markets. Okay, but before we get into analyzing what is the actual connection between exchange rate and current account, let's just say that let's define a couple of simple principal categories. So, first, exchange rate is the price of one currency expressed in terms of other. So, as you see over here, exchange rate is a price of a different currency. So, the exchange rate is telling us how many units of our currency we need to pay for 1 unit of foreign currency, or how many units of foreign currency we need to pay for 1 unit of our currency. And look, this distinction doesn't make any difference, because those two are the corresponding values. However, when we model it, we need to take some sign. And in our case, we will define E as price of 1 unit of foreign currency expressed in terms of domestic currency. Okay, and look, what is this? What is this telling us? Look, if the exchange rate, in our case is for example 3, it means that in order to purchase 1 unit of foreign currency, I will have to pay 3 units of domestic currency. And look, just from that, we can get what is happening when exchange rate is increasing or decreasing. Because look, if exchange rate is going up, so for example from 3 to 5, what does it mean? Well, it means that now, in order to purchase 1 unit of foreign currency, we need to pay 5 units of domestic currency. So more. What does it mean? It means that our currency lost in value. Now we need to spend more of our currency just to buy 1 unit of foreign currency. Okay, so this loss of value of our currency is something we call depreciation. Okay, and look, we can go in a different direction. What if it drops, exchange rate, it drops to 2? It means now that in order to buy 1 unit of foreign currency, I need to pay just 2 units of our currency, which means that our currency became stronger. This situation, the increase in the value of our currency, domestic currency, in terms of other currencies, we call appreciation. Okay, and I know that at the beginning it's misleading because actually depreciation, so loss of the value means that E is getting bigger, and appreciation means that E is getting smaller, but you need to remember that because this is fundamental to everything that we're going to be doing. So please remember this by heart. Okay, so now look. Now we know what is exchange. We defined it. The second thing we should consider in here is how this exchange rate actually affects current account, so trade balance. Okay, and we're going to do it using a very simple example that should demonstrate to you how it should all work. However, let me notice a couple of things. Look, I said here nominal exchange rate. Nominal exchange rate is the exchange rate you would see at the bank or at the exchange. This tells you how many units of one currency you can exchange for how many units of our currency you can exchange for 1 unit of foreign currency. However, we do not know anything about the prices in the domestic and foreign country. So actually, we should concentrate here also on real exchange rate. However, look, ISLM is a short-term model, right? We are assuming that prices are constant. This is why we can observe what happens to other variables. And because we are assuming here prices are constant, and the only price that can actually change is either, well, actually we've got two, interest rate and exchange rate. But for now we are concentrated on exchange rate. We can use nominal exchange rate without losing any generality to what we are actually saying. Actually, the differences between nominal, real exchange rate, and actually you will learn that there is plenty more types of exchange rate, like spot and forward, ask and bid. But we will all discuss this during our class on international economics, where we get into very much details with it. For now, let's just understand why exchange rate affects current account in a way that it does. Okay, and how are we going to go about it? Let's imagine that we've got two countries. One is Poland and one is Germany. Okay, currency in Poland is Polish zloty. In Germany is euro. Okay, so now, okay, let's also take perspective. Let's just say that Poland is domestic or home, and Germany is a foreign country. Okay. Now, imagine also that those two countries are each producing one single good. Poland produces good X, and price of good X is equal 1 zloty. Germany produces only good Y, and price of good Y is 1 euro. Okay, now I'm gonna, I'm gonna simplify everything to the ridiculous extent because we don't want to look at real exchange rates in this class. We will look at those in international economics. So I'm going to start with an extremely unrealistic and simple example. Imagine that the exchange rate that we've got is that 1 zloty can be exchanged for 1 euro. Okay, how does exports work in this situation? Look, please remember one thing. We take the standpoint of Poland. So, this is the set of equations that describes what happens in Poland. However, how does this entire process look here? Imagine a very simple thing. Person from Germany wants to purchase good X in Poland. How does it happen? Well, our German will take 1 euro and it's going to take it to the foreign exchange market and is going to purchase 1 zloty. Then, this 1 zloty will be enough to purchase 1 unit of good X. And of course, this good X is finally transported to Germany. And as a result, we had Polish exports, right? Person from Germany just purchased 1 unit of good X from Poland. Of course, first, they had to exchange 1 euro for 1 zloty. Okay. Now, I'm going to continue over here. Let's just leave what we need. At this moment, I assume that everybody remembers that C is correct. Okay. So, what's happening next? Well, we can also show how the imports works, right? If we've got imports, it means people from Poland are buying stuff from people from Germany. So, how does it work? Well, first, person from Poland needs to take 1 zloty, go to foreign exchange market and exchange it for 1 euro. Then this 1 euro is just enough to buy 1 unit of good Y, and then good Y goes to Poland. So these are inputs. Okay, so now we understand basically the entire mechanism behind the purchases, right? However, what is going to happen if we're going to have either depreciation of Polish zloty, which is of course the same as saying appreciation of euro, or when we have the reverse. Okay, but let's start with depreciation. Okay, so let's say that we've got depreciation. Which means, of course, that E goes up. What does it mean? Of course, we all consider it from perspective of Poland. So look, now, person from Poland, and now, in order to, for example, to exchange, to get 1 euro, we need to pay right? This is depreciation, because now Polish zloty is worth less, right? Now we need to pay twice as much for 1 unit of foreign currency, which is okay. And now look, let's see how in this case first exports of Poland should behave. Look, now our German is still taking €1, but now can go with this €1 to foreign exchange market and get 2 zloty for it. And with this 2 zloty, our German can buy 2 units of good X. And now those are going to Germany. How will the imports look like? Well, in case of imports, now person from Poland takes 1 zloty, go to exchange market, foreign exchange market, and with 1 zloty, how many euros you can buy? Only half, 50 cents, right? So we will get only half a euro. And look then, with half a euro, you can only buy 1/2 of good Y. And this is Polish, this half of good Y are Polish imports. And look, what is this simple example showing us? As a result of depreciation, Polish exports have actually gone up, and Polish imports have actually gone down. Look, compared with the previous situation, we sold twice as many good units of good X, and we bought only half of the units of good Y. Look, what exchange rate does, when exchange rate changes, it changes relative prices of goods in different countries. And look, with depreciation of Polish zloty, we can actually see that it increases competitiveness of Polish exports, because Germany, with the same amount of money, can buy twice as much stuff. However, German exports, so our imports, have become less attractive, less competitive, because with 1 zloty, we can just buy half a unit of food. Okay, before we move on and make some general conclusions here, let's just add here one more. Let's see what happens if we actually have appreciation. We expect the opposite, but let's see. So now Polish zloty should be gaining in value compared with this situation, right? So let's just say that now we've got a case where 1 Polish zloty or for €1, we need to pay just 50 groszy, right? 0.5 of 1 zloty. Okay, what is going to happen now? Let's first look at exports. Well, again, our German just takes €1, exchange it for 50 groszy and is able to buy only half of good eggs. And those are, of course, exports of Poland or imports of Germany. Then, let's look at imports. In case of imports, we start from the perspective of a Pole. So, we've got 1 zloty that can be exchanged for 2 euros, and those can buy us 2 units of blue wine, which later go to Poland. And look, again we see the same situation. Polish imports, but of course in reverse, are now going up, while Germany exports, while Polish exports are going down. So, what is the main conclusion we can get from this exercise? Well, the general conclusion is that exchange rate decides about the relative competitiveness of the economies. The lower is the value of your currency, the higher should be your exports, and the lower should be your imports. So, look, in other words, we can simply put it in the following way. Every time when our currency is depreciating, we should expect export to go up, imports to go down, and this, of course, will cause current account, or maybe like that, becoming worsen, meaning that we are oh my god, of course improving, meaning that we are selling more and buying less. And of course, in the opposite direction, if exchange rate is appreciating, we should expect lower imports and higher exports. Now our currency is worth more, so we will observe actual fall in current account. Okay, and look, the only parameter in this model we haven't thus far established is V. Right? V is actually telling us what is happening to current account when exchange rate is changing. So, in other words, we can describe it using partial derivative CA with respect to E, right? And look, if I differentiate this function with respect to E, the only thing I've got is V. And we know that the lower is the value of our currency, so the bigger the E, the better is the position in our current account. And the lower is the value of E, so the higher is the value of our currency, the worse is the position of the current account. So we can conclude that V is positive. And look, with this, we've actually established that the impact of exchange rate on current account, right? So we know that depreciation will lead to trade surplus, appreciation will lead to trade deficit, right? Okay, so now look, we know all this, we can get back to building up our model and finally finding IS curve. And this is what we're going to do now. Okay, so let's start substituting things when we can. So let's first combine the first two equations. Now, instead of CA, I can substitute this. Right? And now, also, instead of, I can substitute for C and for I. And we remember that if I substitute T over here and 1 minus T into YD, I'm going to get B times 1 minus T times Y, right? Of course. And, I'm sorry, it's A. Now, instead of I can write plus D minus AI, and the rest, and the rest is already here. Okay, and look, at this moment, we can already say that we've got formula for IS, but let's do it the way we like it, and let's organize it in such a way that we put all endogenous variables on the left-hand side and the exogenous on the right-hand side. Now, what are going to be our endogenous variables? Well, first, income. This is not changing. Now, second is of course interest rate. And the new endogenous variable that we're going to have from this model is exchange rate. We're going to use actually the ISLM BP to find the level of exchange rate. Okay, so with this I got 1 minus B, 1 minus T, Y, plus A, I, and minus V, E. Okay, and here we just have exogenous terms A plus D plus G0 plus X, 0. Okay, and what we see over here is the IS curve. Now, next thing we need to do is, of course, to draw it. And look, we're going to draw it just as before we did with the regular ISLM model. We're going to draw it in a space, income, interest rate. Right? So in order to find the slope of IS, I need to calculate the differential. So I differentiate this expression with respect to y and I, because those are the two variables present here. Okay, and look, what am I getting? I'm getting 1 minus b times 1 minus t dy plus e times di. And look, everything else over here has it doesn't have either I or y, so it's equal to 0. Okay, now we need to solve this to get derivative di dy. So first I'm going to move this to the other hand side of the equation. So I'm going to have negative Okay? I'm sorry, I missed this one, but it's now already here. So we've got 1 minus b, 1 minus t plus m d y. Right? And now look, what am I doing? Now all I need to do is to divide both sides by dy and by e. And I'm getting then dy is equal to negative 1 minus b, 1 minus t plus m over e. Now, the only thing left is to assess whether this expression is positive or negative. Look, we know that this is between 0 and 1. This is plus m, so it's even bigger. So this is definitely positive. E is also a positive parameter. We've got minus up front. We can be sure that this is negative. And this is how we know that IS curve is actually downward sloping. Okay, so we finished with IS curve. We know what is the formula for IS. We know what is the impact of exchange rate on current account, so on trade balance, and we know the slope of IS. Right? So at this moment, we can finish with IS curve. Let's just now go to LM. And actually here is a very, very good news, because in case of LM, nothing changes. What do I mean by nothing changes? Well, look, money market is a domestic money market. So in this case, exchange rate and generally other considerations will affect it indirectly, but not directly. So, in this case, in case of LM curve, we will still have money demand given by KY minus LI, money supply set by central bank, and money demand equals money supply equilibrium condition, right? So LM still has the formula KY minus LI equals to M0. This is our formula for LM curve. And of course we can easily find the slope simply by differentiating this equation. We're getting that this is K dy minus L di equal to 0. And we get that di over dy is equal to K over L, which we know that it's positive. So look, here nothing changes. We are still going to have upward sloping LM curve. Okay, so what do we actually need now is to extend our model by introducing directly interactions with the rest of the world. And we're going to do it using BP curve. But BP is a shorthand for balance of payments. Balance of payments simply registers all transactions between domestic somebody from home and from foreign, it ends up in balance of payments. Why is that so? Look, every time when somebody from one economy wants to trade with somebody with the other economy, they actually need to do it in a given currency. They need to either buy or sell some currency in order to make a payment. So every transaction that actually results in exchange of currency will affect balance of payments, right? And look, now let's look at it from the other perspective. Balance of payments is recording people wanting to buy our goods, wanting to or willing to sell goods to us. It's recording every asset that somebody from other country wants to buy, or any asset in other country you want to buy. So actually, with balance of payments, so with BP curve does is that it reflects a demand and supply for domestic currency. How this process works, we will establish in a second. Let me just tell you a couple of things. Look, if people from outside the world want to buy our products, they need to purchase our currency. So demand for our currency goes up, right? Or when we want to buy goods from a foreign country, we need to buy foreign currency, and then the supply of our goods, of our currency goes up because we want to sell more of our currency in order to purchase some of foreign currency. Okay, and look, this actually leads us to a very specific result that we're going to use. When balance of payments is at zero. So it means basically everyone has enough of foreign currency, just enough as they want it, given the conditions. We might say the exchange rate is in equilibrium. What does it mean is that if exchange rate is in equilibrium, is that there are no forces either creating pressure on appreciation or depreciation. Okay, but now let's get into it a little bit from a little bit different perspective. And look, balance of payments registers all the transactions between foreign and domestic residents. Of course, we will not include all of them in our model because that would be too complicated. However, BP, balance of payments, already has inside something that we know, and this is current account. Current account is a part of the balance of payments that register, in our case, trade. However, it's not enough. The second account that we are going to include in our considerations of ISO and BP model is capital account. And look, capital account registers registers changes in ownership of international assets. Okay. We, for simplicity, will be only considering one asset. But look, it doesn't really matter, because if we introduce more assets, we would get exactly the same result and everything would just get really, really complicated. Our assets are going to be bonds. Domestic bonds yielding some interest rate, and foreign bonds yielding some interest rate. So look, every time when foreigners buy our bonds or we buy foreign bonds, those transactions will be recorded in capital account. And look, when do you want to buy domestic assets? Well, okay, I'm not going to tell you this now. Let's consider this. Look, let me just first show you what is the formula for current account, capital account. Capital account formula is W times I minus I. W, where IW is simply world interest rate. Okay, so we are assuming that there is some exogenous or given interest rate from the rest of the world, and now what we want to do is to know how the interplay between domestic interest rate and foreign interest rate will create some movement in the capital account. Okay, so how do we do it? Let's consider a couple of cases. Okay, so if case number one, what if domestic interest rate is bigger than world interest rate? Look, this implies that which assets are more attractive, domestic or foreign? Well, of course, I would assume you would prefer to have a bond that gives you higher interest. So in this case, actually we can say that domestic assets, but of course we think bonds, are more attractive than foreign. Okay, so in this case, if our assets are more attractive, what should we expect? Well, we will expect capital inflow. Why? Look, because what is rational thing to do? Foreigners should buy our bonds, and we don't want to buy foreign bonds. What does this imply? It means demand for our currency goes up, right? Okay, let's write demand for domestic currency goes up, and demand for foreign currency goes down, right? Why? Look, because our assets are more attractive, so we don't want to buy foreign assets, so we don't want their money, we don't want their currency, right? On the other hand, our interest rate is higher. They want our money, and the demand for our currency is high, right? So money is actually going into our country because foreign residents are buying our assets. And look, if this is the case, if there is higher demand for our assets and lower demand for for our currency, lower demand for foreign currency, we should expect something that we will call pressure on appreciation. Why pressure on appreciation here? Because look, if there is higher demand for our currency and lower demand for foreign currency, we expect that the change in the currency will be causing increase in the value of a domestic currency. Okay, and look, this example should, like, understanding this, we can right away analyze the reverse situation. So if our interest rate is lower than our interest rate, we see that foreign assets are more attractive than domestic. So what our economy is going to be experiencing? Well, capital outflow. And look, if now our residents don't want to hold our bonds, and foreign residents don't want to hold our bonds, the demand for domestic currency is going down, and demand for foreign currency, because if we want to buy a foreign bond, we first need to purchase, of course, foreign currency. Oh, this is very important. Remember, if you want to buy Polish bond, you need to exchange dollars, euros, whatever, into zloty. If I want to buy euro bond, I need to purchase it in euros. If I want to buy a treasury bond from the United States, I need to pay in dollar. So, depending on which bond you want to buy, you need to, of course, purchase a currency first in order to do so, right? So, in this case, as demand for domestic currency goes down and domestic for foreign currency goes up, we will expect pressure on appreciation, on depreciation. Depreciation. Okay, and finally, if interest rates in domestic and foreign are the same, then both type of assets, so our and domestic bonds, are equally attractive, and it means that there is no capital flows and no pressure on change in the value of exchange. Okay. So look, what can we, based on that, deduce about capital accounts? We will see that every time is higher than the foreign interest rate, we will have inflow of capital into our country because we have more attractive bonds. Then, in order to purchase those bonds, foreign residents will have to actually purchase our currency, right? And this will cause pressure on appreciation. Okay, and look, of course, here we see the reverse. And based on solely that, we can conclude that the derivative, partial derivative of capital account with respect to our interest rate should be positive, right? But it's equal to W. And this is how we get the last element of the model, which is W, and we see that this coefficient must be positive. Because look, only then, if interest rate in our country increases, we see capital inflow, and when interest rate in the rest of the world increases, we will see capital outflow. And look, I actually mixed here two types of information. Well, first piece of information that we wanted to have here was what is the impact of interest rate on capital account. And we see this over here. But look, I also sneaked in a different piece of information over here. What happens to exchange rate if this capital account is not balanced, so it's not at zero? It creates a pressure on appreciation, on depreciation. Higher interest rate in our country creates a pressure on appreciation of our currency, and higher interest rate in the rest of the world will create a pressure on depreciation. But look, if this works in case of trade in assets, why would wouldn't the same mechanism work in case of trade? And look, it is exactly the same way with trade as we have here with capital flows. Let me illustrate that very easily. Okay, think about it this way. If we've got a situation that exports are higher than imports. What does it mean? Look, it means that foreigners buy more of our goods than we buy of their goods. So, who needs more of somebody else's currency? Well, of course, in this case, foreigners needs more of our currency to buy our goods than we need theirs, right? So look, in this case, we see that every time when exports are higher than imports, foreigners must have create higher demand for domestic currency, right? But look, if there is a higher demand for domestic currency, value of our currency is going to go up. Remember, this is appreciation. And when our currency appreciates, exports fall, and imports go up. And look, okay, before we actually get to this one, to get to the final conclusion, let's consider the opposite. Now look, if exports are lower than imports, This means that we buy more of foreign goods than they buy of our goods. But this means that the demand for foreign currency is higher, right? Which again, because now we need more of foreign currency to buy their goods. This will create a pressure on depreciation, and depreciation improves exports and worsens imports. But look, what is the final outcome in both of these cases? Look, as long as exports are higher than imports, there will be pressure on appreciation. And this pressure on appreciation will disappear when exports are exactly equal to imports. And look, here we've got the same situation. If exports are lower than imports, we will see higher demand for foreign currency, depreciation of domestic currency, improvement of the current account, so higher exports, lower imports. And as you see, current account gets back into its balanced position. So, another thing that we learned from this is that both current and, on one hand, current and capital accounts are influenced. Well, current account is on one hand influenced by exchange rate, but it also influences exchange rate. And look, this is the main thing. We said that current account, that BP, so balance of payments in our case, is made out of two parts: current account and capital account. And look, each of these accounts separately will create a pressure on exchange rate. Look, if it turns out that current account is in surplus, and let's just say and capital account, their sum is in surplus, what does it mean? It means that foreign residents need more of our currency than we need their currency. So here we will always have pressure on appreciation. So E goes down. However, if the sum of the pressures from current and capital account happen to be negative, it means that we need more foreign currency than foreigners in our currency, which results in pressure on depreciation. Right? So finally, when can we have a situation if there's no pressure on exchange rate? As we already said, BP must be equal to 0. And only then, if BP is going to be equal to 0, we're going to have a situation when exchange rate market is in equilibrium, and we will get equilibrium exchange rate. Okay, so finally, let's derive the BP curve and let's see what is the slope of this BP curve. Okay, so our BP curve, or BP equal to 0 curve, is paid out of current account requires that current account and capital account are both equal to 0. Which means that current account given by x0 minus my plus VE plus WI minus IW equals to 0. And look, already this is the formula for equilibrium in so for Bp curve. But as we do it always, let's put all the endogenous variables on the left, exogenous variables on the right. And we get then that this is negative my plus wi plus we, right? And now x0 goes to the other side, so we've got negative x0, and here we've got plus wiw, right? Remember, because there's a minus, we move it up to the other side, it's plus. Okay, so now the final thing would be, of course, to calculate the slope of Bp, so we can put it somewhere here. Again, we make a total differential. Well, we make a differential with respect to income and interest rate. So we get that this is negative m dy plus wi equals to 0. Oh, I'm sorry, plus w di equals to 0. Now look, we can easily move this on the other hand side of the equation. So we get that w di equals to m dy. Now, dividing both sides by w and dy, we get that the slope of Bp given by derivative di dy is equal to m over w, which we already assessed are both positive numbers, which means that the slope of Bp is also positive. So we can draw Bp over here, let's just say like that. And this is it. This is all the information that we actually require in order to put ISLM Bp model together. But there are questions, of course. Like, okay, both of these lines are upward sloping. But how do I know which one is steeper? This is a question we will be discussing here. Generally, we will discuss it in length during international economics. Okay, and the final question is, okay, do those three curves actually intersect at one specific point? And the answer to this question is going to be a topic of the next video, in which we are going to find equilibrium. We're going to prove that there exists equilibrium in linear ISLM Bp model. Okay, thank you for your attention and see you in the next video.